So, chapter 4, test review, looking at number 1. It says, talking about direct variation and inverse variation, I just want you to focus on inverse variation. Okay, the inverse part, it's when one's increasing, one's decreasing. So, do you agree x is increasing? Okay, is y decreasing? Yes, so good, we're at an inverse. Now we need to know if they have a variation. How do I know? Multiplying x and y. So 2 times 10 is 20. 4 times 5 is 20. Can I assume all of these are 20? No, you have to actually figure it out. 5 times 4? 20. 20 times 1? 20. So is this inverse variation? Yes. If I, for example, had another row here and I got 21, is that an inverse variation?
No, it's direct.
No. Even if it was, if you said no, all I would need you to put is just no.
Oh.
Yep. Okay.
Will you count it wrong if we put inverse or direct?
Yes, I just want you to put yes or no.
So you'll count it wrong if we put it.
Part B, do you agree is the exact same thing as part A?
Yeah.
Okay, that's not going to happen on the test, but do I need to go over that again? No. Okay. Number two, what equation are we going to use? Y equals k over x. Write that down. Y equals k over x. Now, this problem, you're going to pretty much do it twice. Okay? So for the first one, you're paying attention to what A gives you. X equals 7 when y equals 2. We're going to use that to solve for our k value. So I have y equals k over x. What's k?
14.
Oh, sorry. What's y? 2. Do we know what k is? No. What's x? 7. How do I solve for k? Multiply by 7, so I'm left with k equals 14. Now, is k equals 14 my answer?
No.
No, because in the directions it wants us to find y when x equals 10. So, this is kind of part 2 of the problem. Okay, I'm going to still use the same equation, y equals k over x, but now we're using the question. Do I know what y is?
No.
I do not know, because I'm trying to find y. What's k?
14.
Just found it. Yep, k is 14. What's x?
10.
10. So, can I divide 14 divided by 10?
Yeah.
Nope, so we're just going to simplify. What does it simplify to?
7 and 10.
7 over 5. Yep, I divided both of these by 2. So my answer is y equals 7 over 5. So on part B, what do I start with? What information do I start with?
Y equals k over x.
Right, the y equals k over x, and I'm using what they give us, x equals 2 when y equals 5. So what's my y value? 5 equals, do I know what k is? No, what's x? 2. How do I solve here? Multiply by 2. So I'm left with k equals 10. Is that my answer? No. Moving on to the next part. Okay. Still dealing with y equals k over x. Again, I'm using the question now. Do I know what y is?
Yes. No.
I do not know what y is. What's k? 10. What's x? 10. Can I divide 10 divided by 10? Yes. What's 10 divided by 10? 1. Is everyone understanding the outline of this question? Okay. So you're really doing the same equation 2 times with different information. Okay? Moving on to number 3, talking about vertical and horizontal asymptotes. What is an asymptote?
The boundary.
It's like a boundary line. Like in a graph, the graph will never touch that line. So I'm going to come over here. I want you to write these notes somewhere. Okay? So how do I find vertical asymptotes? How do I find vertical asymptotes? Yep. We're going to set the denominator. What's denominator mean?
Bottom of the fraction.
Yep, the bottom of the fraction. Set denominator equal to 0. Okay. Sometimes you might have to factor so that you can solve. Okay, set denominator equal to 0, factor, and then solve. Okay. What about horizontal asymptotes.
You're gonna take the whole fraction.
What are we comparing on these ones? Compare the degrees. Compare to the degrees of the numerator and the denominator. Okay, and then remember with the horizontal asymptotes, this came with the 3 different cases. That tells you what the answer is. Okay, and you can use those cases on your notes. You can use those for your...
We can use our notes.
Yep, you can use your notes. Okay, so those 3 cases, we wrote those down during section 4.2. If you need to go back and look at that video, go do that for those. Okay, so these are from section 4.2. So, going to an example on A. So first thing I want to do is I'm just going to find the vertical asymptotes first. What does it tell us to do for vertical asymptotes? Set the denominator equal to 0. Do you agree my denominator is x squared minus 9? So x squared minus 9 equals 0. Okay, sometimes we may have to factor and solve.
Yes.
I have to factor, right? How do I factor?
X plus 3 minus
X minus 3 equals 0. Now how do I solve?
You set those ones equal to 0.
You can do the opposite, or what really is happening is we're setting both of these equal to 0. And then solving. Over here I subtract 3, so I get x equals negative 3. Here I add 3, so I get x equals positive 3. So those are my vertical asymptotes. Am I done with this problem? No, I need to find the horizontal asymptotes. So for horizontal, what did it say we need to do? Compare the degrees. So what does degree mean? It's the highest exponent. Okay, what's my highest exponent in the numerator? 2. What's my highest exponent in the denominator? 2. Ask yourself, are they equal? Yes. What's the case say if they're equal? What do we have to do? Where'd you get that from?
Don't you like
It's okay. If they're equal, yep, we're gonna divide our leading coefficients. What's a leading coefficient?
2.
It's the number in front, right? So our leading coefficient on the top is 2 divided by leading coefficient on the bottom.
1.
It is 1. So what's 2 divided by 1? 2. How do I write horizontal asymptotes? Y equals 2. Looking at part B, we're doing the same thing. Looking for vertical asymptotes. How do I find vertical asymptotes? What am I doing with the bottom fraction? Yep, take x squared plus 7x plus 10 equal to 0. What do I need to do first before I can solve? Factor. What are factors of 10 that add up to 7? Does everyone agree with 5 and 2?
Yes.
How do I write those as factors?
X plus 2, X plus 5.
X plus 2, x plus 5 equals 0. How do I solve? Set them equal to 0. X plus 2 equals 0. X plus 5 equals 0. What do I get for x plus 2? X equals negative 2. And for x plus 5, I get x equals negative 5. Those are my vertical. How do I find horizontal?
Take the fraction and
Look at the degrees. Yep. What are the degree of the numerator?
1.
Right. If there's no exponent, you can assume it's 1, right? So 1, and what's the denominator?
2.
2. Are they equal?
No.
No. Is the numerator less than or greater than?
Less.
Numerator's less than. What does your case say if the numerator is less than the denominator? Y equals 0. Yep. If the numerator is less than the denominator, by one of your cases, it says y should equal 0. Okay. And then the last one in this section, do you agree we're going to keep doing the same thing? Okay, so vertical asymptotes, how do I find those? Set the bottom part equal to 0. So tell me what I need to write. X minus 2 equals 0. What's nice about this one? Right, is it already... Right, you don't have to factor or do anything. So all I have to do to get x by itself is add 2. So x equals 2. That's my vertical asymptote. How do I find horizontal? It's the degrees, right? So what is my degree of the numerator? 2. Degree of the denominator is 1. Are they equal? No. Is the numerator less than or greater than? Greater than. If the numerator is greater than the denominator, what is my horizontal asymptote?
None.
None. Yep, and we got our horizontal asymptote answers from those 3 cases in 4.2. Yep. Starting with number 4, we are getting to our rational expressions. Again, what do I mean by a rational expression? Fraction, right? Yeah. Rational expressions are our fractions. With these ones, all it's asking us to do is simplify. How many fractions do we have on 4a?
1.
We only have 1 fraction, right? So there's no operation happening. I'm not subtracting, adding, multiplying, and dividing rational expressions, okay? When we have 1, all I have to do is just simplify the top and the bottom. Okay, so we're going to take it one at a time. What can I do with 4x plus 6? Take out what? Take out a 2. If I take out a 2, what's left? 2x plus 3. Can I do anything with 2x plus 3? Nope, they have nothing in common, so I'm just going to keep it. What can we do next?
Cancel.
Right, this is our favorite step. What can cancel out?
2x plus 3.
2x plus 3, so what is left? 2. So on 4a and b, all we're doing is we're just simplifying. So on b, what do I need to do?
Factor.
I need to factor the top and the bottom. Remember, again, look at it one by one. What are factors of 40 that add up to 13?
8 and 5.
It is 8 and 5. Does everyone agree? How can I write 8 and 5 as factors?
X plus 8.
Yep, x plus 8, x plus 5. Same thing on the bottom. What are factors of negative 35 that add up to negative 2? It is 7 and 5. Does everyone agree I need to make that a negative 7?
Yeah.
How do I write those two as factors?
X minus 7.
X minus 7, x plus 5. What do I do next?
Cancel.
Yep, once you have them simplified, all you got to do is start canceling some things off. What can cancel? X plus 5. That's it. So I write what I have left. What's left on the top? X plus 8. What's left on the bottom?
X minus 7.
X minus 7. Biggest thing to remember is wherever it's left at, you have to keep it there. You can't just magically put it on the top. Okay, they have to stay in their spots. Flipping to number 5. What I want you to understand on number 5, do not get flustered with it because it is the same as number 4. Same thing as number 4, but what's happening this time is that we have what?
2 fractions.
We have 2 of them. And what operation's happening?
Multiplication.
You have multiplication and division. Write that down, just so you have it as a note. Multiplication and division. So we don't have to worry about common denominators yet. That comes when we're doing adding and subtracting. So here, we're really doing the same thing. We just have multiple fractions we have to look at. Okay, so what should we do to get started?
Cancel.
That's going to be the very last thing we do. What do we have to do before we can cancel?
Don't you simplify?
We're going to simplify. Yep, look at all of them separately. How can I simplify x squared minus 5x? Take out an x. What's left?
X minus 5.
Everyone with me? Okay, what can I do with x squared minus 3x? Take out an x, so I'm left with x minus 3. Am I done with that fraction right now? I'm done right now. Can I do anything with x plus 3? Nope, that's in simplest form. Can I do anything with x minus 5? No, that's in simplest form. Since it's multiplication, we don't care about a common denominator. Remember, at this step, we can just treat it as one big fraction. So now we're at our canceling out step. What cancels?
X minus 5.
X minus 5.
X.
The x's. Can these x minus 3, x plus 3 cancel?
No.
Why not?
They're
They're not the same. Okay, so what is left?
X plus 3 over X minus 3.
Over x minus 3. Yep, since x minus 3 is on the bottom, it has to stay on the bottom. Okay. Are we seeing how it's very similar to number 4? Okay, so let's look at B. What do I need to do first with multiplying in rational expressions? Simplify. So if I'm looking at 5y minus 20, ask myself, what can I take out? Take out a 5. What's left? Y minus 4. What can I take out of 3y plus 15? 3 to get y plus 5. Good. What can I take out of 7y plus 35? 7 to get y plus 5. What about 10y plus 40? 10 to get y plus 4. Again, since it's multiplication, we can think of this as one fraction. What can we do next? Canceling some things off. What do I got? Y plus 5. Is there anything else? What do you notice? We have a lot of numbers. Okay, what I mean by numbers is we have like 5, 3, 7, and 10. I want to see if I can simplify those.
Can't you combine the terms?
That would be multiplying them, yes. But before we do that, is there anything we can simplify?
Distribute? Do you take something?
The 5.
Yeah. Do you agree 5 and 10 relate to each other?
Yeah.
How many times does 5 go into 10? Sorry, how many times does 5 go into 5? 1. How many times does 10 go into 5? Twice. 5 go into 2. Sorry. Thank you. Okay. Can I do anything with the 3 and the 7? Nope. So let's write what we have left. What do I have left on the top? Yep.
1y minus 4.
And 7. Yep. I don't care how you write it. I'm just going to write it like this. As long as you have all of that on the top. On the bottom, what should I do with this 3 and 2? Multiply. 3 times 2?
5.
6. And then what's left? Y plus 4. Now am I done? Yes. Last one here. What do you notice about C? It's division, so we have to do what first? Write that down. Keep, change, flip. What does that mean? What does keep mean? Keep the first fraction. Change the sign from division to multiplication. Flip means not the signs.
No, you gotta change the flip it.
Flip means we're flipping the fraction. Are any signs changing? No, we're just flipping the fraction. Okay, now it's a multiplication problem. We know how to solve multiplication problems. What do I need to do first?
Factor the numerator.
Factor. What do I need to do with this?
Factor 4.
What are factors of 4 that add up to -5?
4.
And what do I need to do with both of them?
Negative.
Make them negative. How do I write those as factors? X minus 1 and x minus 4. What does x squared minus 1 turn into? X plus 1, because it's one of those perfect squares. X plus 1, x minus 1. What about x squared plus 5x plus 4?
Factors of 4 that make 5.
Yep, which are
1 and 4.
1 and 4. Do I need to change them?
No.
Nope. How do I write 1 and 4 as factors?
X plus 1. X plus 4.
Yep. And then that bottom one there, x squared minus 9, turns to
9. X minus 9. X plus 9.
close.
No. X minus 3. X plus 3.
There you go. Yep, perfect square. Again, it's multiplication, so we can turn this into One big fraction. What step are we at? Cancel. What do we got?
X plus 1.
X plus 1.
X minus 1.
X minus 1.
That's it.
That is it. So what's left on the top?
X minus 4 times X plus 4.
Mm-hmm. Over.
X minus 3 times X plus 3.
Good. Good job. Now we're getting to number 6. What do you notice about number 6? It's adding and subtracting. Write that down. Addition and subtraction. What do we have to look out for now? What do we need? We need a common denominator. Write that down. We need a common denominator. Circle it, star it, something. We need that common denominator from here on out. Okay. So, that's the first thing we need to find. What's my common denominator for 6? Do you agree they both already have y minus 5? Yep. So, since they already have that common denominator, I have y minus 5. What do I do with the numerator? Combine like terms. Yep. So what's 6y plus 3y? 9y. Negative 4 plus 1. Minus 3. What can I do with that top part? We always want to see if we can simplify. Take a 3 out, so I'm left with 3y minus 1. Yep. Divided by y minus 5. Remember, your denominator will never change until you start crossing things out. Okay. Can I cross anything out? No, so we're done. Okay. Again, with adding and subtracting, what do we have to look for first? Common denominator. Do I have common denominator?
No.
I do not. What should I probably do with this right here? Factor. Okay, so I'm kind of going to rewrite what we have here. So I have x plus 2. How can I factor this?
Factors of 4 that equal 4.
Factors of 4 that equal 4. What do you got?
2 and 2.
How do I write those as factors?
X plus 2 times X plus 2.
X plus 2 times x plus 2. Plus, can I do anything with this fraction? No, it's already simplified, so I can leave that as 2 over x plus 2. Now, can we see a common denominator?
Yes.
What do they have in common? X plus 2. What should our common denominator be?
X plus 2.
Should be both of them, yep. Common denominator is x plus 2, x plus 2. Do you remember what our next step is to make them a common denominator?
Multiply the one that you say.
Right. Correct. Is this denominator missing anything?
No.
No. What is this one missing? It's missing an x plus 2. So I'm going to multiply the top and the bottom by x plus 2. Now look, do you agree that I have common denominators? Okay, so my common denominator is x plus 2 times x plus 2. Look up here real quick. Did I do anything with this? No. So that stays as x plus 2. What about this? I have to distribute. Yep. What's 2 times x? 2x. What's 2 times 2? 4. Are we done yet? No. I'm going to come down here. What do we need to do on the numerator? Combine like terms. Is my denominator going to change right now? No. Denominator stays the same to the very end. What is x plus 2x? 1x plus 2x is 3x. What's 2 plus 4? 6. One more thing we got to do. Yep, simplify. What can we take out of 3x plus 6? Take out of 3. What's left? 1x plus 6 divided by 3? 2. Did I do anything with my denominator? Nope. What's the very last thing we're going to do? See if you can cancel out. How many x plus 2's cancel out? Only one. So what is left on my numerator? Yes, 3 over x plus 2. Jumping up to C. What do you notice about C? It's subtraction. However, does our process change? No. What should we do first just so we don't have to worry about it? Change the sign. So we're going to change, but exactly what you said is correct. We're going to change this subtraction sign to addition. What signs change? Yes, the numerator, the number on top. Only in the second fraction. Okay. What do we need to look for? Common denominator. Do we have them? No. What do we need to do? Right. What can I do with 4y plus 8? What can I take out? Take out a 4. What's left? Y plus... What's 8 divided by 4? 2. Plus... what can I take out of y squared and 2y? A y, right? What's left if I take a y out? Y plus 2. So what is my common denominator going to be? And 4 and y. Yep. So what is this fraction missing? It's missing a y. So I'm going to multiply by y on top and bottom. What is this fraction missing? A 4. So I'm going to multiply by 4 on the top and bottom. So simplifying what I have, what is my common denominator? It's that 4y, y minus y plus 2, right? Okay. What happens here? Right, so y times y is y squared. Negative 1 times 4. Negative 4. What do we need to do? Can't cancel yet.
You need to make that top one, like, simplify.
Yep, we need to factor and simplify. What can this factor to? It's a perfect square.
Y minus 2, y plus 2.
Yep, y plus 2, y minus 2. Did anything happen to my denominator? No. Favorite step? Cancel.
Y plus 2.
Can I cancel these two y's out? No. So what's left?
Y minus 2.
Y minus 2 over 4y. Last section, number 7. What do you notice about this section? We're solving. I want you to circle that word solve. We are solving. We know that because it says solve and because we have an equal sign. Okay, so we're going to get actual x equals something for our answers. Okay. What do we have to make sure we have here?
Be the same on both sides.
Common denominator. Yep, write that down. Common denominator. Because remember, do we like fractions? No, so our goal is to get rid of them so that we can solve. Okay, so common denominator. Do I have a common denominator on A?
Yeah.
What is it?
X plus 2.
Everyone agree with x plus 2? Okay. What do I do with that common denominator to get rid of the fractions?
To the top.
I'm going to multiply every term by x plus 2, just to the top. This should get rid of our fractions. Okay, because what happens with this first term? Right, x plus 2's cancel, so I'm left with 4 equals, what happens to this term?
X.
Cancel, so I'm left with x. So how do I solve?
Then you just nothing because it's already solved.
Right, it's already x equals 4.
Isn't that so great?
Okay, so let's look at B. What do you notice about B?
There's 3 of them.
There's 3 of them. What should we do to make this look nicer?
Make it a fraction. Put it over 1.
Put it over 1. Okay, what do we need to get first?
Common denominator.
CD.
What is our CD?
X plus 3.
Everyone agree with x plus 3? Okay. What do I do with that common denominator? multiply it by every term, right? The reason we're doing this is to get rid of our fractions. This first term, does anything cancel out? No, so what do I have to do on the top?
You have to just multiply and distribute.
2 times x is 2x. 2 times 3, 6. Minus, what happens on this term? Cancel, so I'm left with 1. And then this term over here, what happens? Cancel out, so I'm left with 1. Do you agree all my fractions are gone? That's the whole goal of that first step. What can I do on this left side here? Combine like terms. 6 minus 1 is 5. How do I solve? Subtract 5. So we have 2x equals negative 4. Last step. Divide by 2. X equals negative 2. Last one here, part C. What do you notice about part C?
There's not a common denominator.
Right, we don't have a direct common denominator. What do we need to do?
Make one.
Make one. How? What do I need to do with this?
You need to take that apart.
I need to factor that part, right? Can I do anything with this?
No.
Nope. Can I do anything with this? Nope. What about that last one? What is this factor to?
X minus 3.
And?
X plus 3.
Yep. Now can we see a common denominator?
Yeah. Now we just gotta times it by the other one.
Right, what is our common denominator?
X plus 3.
Both of them. Yep. So what do I do with that common denominator? Multiply it to every term. So multiply by x plus 3, x minus 3 to everything. Okay. Look here, what happens on this first term here?
Cancels out the X plus 3.
X plus 3's cancel. What do I do with what's left on the top? I have to multiply. Yep, distribute. 2 times x, 2x. 2 times negative 3,
Minus 6.
negative 6. Now we're on to the second term.
Negative X 3 cancels.
X minus 3 cancels, so what am I left with?
1x plus 3.
Distribute the 1. 1 times x is x. 1 times 3, 3. What happens on the right side?
It cancels out completely.
Does everyone agree everything's gone?
Yeah.
What's left?
6.
6. Are our fractions gone? Yes. What should I do with this left side here? Combine like terms. 2x plus x. 3x. Negative 6 plus 3. Negative 3 equals 6. How do I solve here? Add 3. 3x equals 9. Divide 3. X equals 3. Nice job.